So I want to try to pick up where Lauren just left off, assuming you are lucky enough to get some data that an algorithm produced and hopefully some real-world results to compare it to. What do you do? Just to contextualize this, we've been talking a lot about algorithmic bias today. That is one segment of machine ethics, which is a very broad field. So we're just looking at this one thing, but there are stories in all of these other areas. Just what is this idea of fairness in a quantitative sense, right? We're using data and we're trying to get fairness out of it. So what does fairness look like in the data? Well, I thought I would give you a little demo of a workbook that I used with some of my students. This actually replicates a Boston Globe story from 2003 on who gets a ticket, who gets a warning. So when you get data, in this case police stop data, it's going to look something like this, right? You've got one row per stop, and it says why it stopped them, and it says their race. And the first thing you do is you just pull out, let's say, all of the stops for speeding where they got a ticket, so that cuts it down by about half, and then group by this minority column, which is just this field that has two entries, minority or white, and ultimately you end up with something like this. So now you have the number of stops, the number of tickets given to white drivers versus non-white drivers. So what do you do with this? Right? This is the first thing you're going to get when you actually look at this data. All of the rest of the talk is about trying to interpret a chart like this. Is this fair? Is this evidence of bias? What do you think? What can we say from this?
There might just be that many more. It's representative of the population.
Yeah, so I heard people say we should compare it to the population. There might just be more white drivers, right? Sort of concepts like this. So what I'm getting at is we actually have fairly sophisticated concepts about what fairness means already, and they don't always map immediately to the data. I also want to say before we dive into this, I would be surprised if you agreed with everything that I said. We are talking about concepts that are difficult to get a handle on, that have a long history of really horrible stuff, and that are often very high stakes. So this is sensitive and complicated stuff, and please come chat with me afterwards, and we can all learn together. So let's interpret this graph. So here are some concepts of what fair could mean in this context, right? You might want to compare it to demographics, but which demographics? Census data gives you resident demographics. We're stopping people on highways. Do people drive in the same proportions as they live? Probably not. And then you get into the whole question of, well, are white versus minority drivers driving the same way? Do they drive at the same speeds? Do they drive at the same highways? Do they drive in places where there are more cops versus fewer cops? There's all of this question of, are we really comparing apples to oranges here? And in fact, there is a legal concept that captures our intuition about these types of notions of fairness. The concept is similarly situated. I've just reproduced the definition from a legal dictionary. And throughout this talk, I'm going to try to tie sort of moral and legal and mathematical principles together. And this is actually a concept you'll see in a bunch of places, including employment law. And the basic idea is, the question is not whether you deserved a promotion and you didn't get one. The question is whether someone who is just like you, except for a protected class, got a promotion. And that's what similarly situated means. So applying this to traffic stops, the question is sort of like, someone who's driving in the same place at the same time in the same way, they should be treated similarly. This concept comes up in a bunch of ways. So this was a nice piece that the Herald Tribune did on bias in sentencing of black defendants in Florida. And The idea here is that there's this standardized point system that is sort of encapsulates the defendant's previous criminal history, and people with the same number of points, that is sort of similar previous criminal history, should get similar sentences. To do this analysis, this is from the write-up on it, the first thing they had to do is make sure they were comparing like people. So they grouped defendants who committed the same crimes according to the points they scored at sentencing. So they put everybody with 30 to 39 points in the same bucket, and then compared between races within that bucket and repeated for all of the other buckets. Right? So this idea of similarly situated ends up in your data analysis. This is a simple example of it. You may have also heard the phrase controlling for. We regress sentence on criminal history, or we regress sentence on race controlling for criminal history. When you hear this concept controlling for, this is the idea they're invoking. They're trying to get some approximation of comparing the same thing. One way we can get at this a little bit in the data that we have is, and this is why I chose this data set, we not only have tickets, we have warnings. So when the cop stops somebody, you can give them either a ticket or a warning. For a few months in 2001, Massachusetts recorded warnings in their database. Most police databases, at least the ones that are easy to get, do not include warnings. So you don't know when someone got off. And so that's a way of controlling for the other circumstances. And if you look at these ratios, right, so it looks like it's about equal tickets and warnings if you're a white driver, but you end up with, more likely than not a ticket if you're a minority driver. And now you start to be able to make a comparison where you can say, okay, something is going on here, right? This doesn't look quite fair because people in the same situation are being treated differently. And so that's what you're looking for. You're looking for some way to level the playing field in your comparison. This has, in the prediction and machine learning literature and quantitative fairness literature, this is often called calibration. The basic idea of this type of fairness is that a prediction or an outcome means the same thing for the people in each group. So I've given sort of a few examples of what this could mean, right? So going back to the ProPublica case or the risk assessment case, you're looking at the same percentage of rearrest for defendants who scored at a particular level. So say they were classified as medium risk, they should have the same percentage of ultimately going on to be rearrested for something regardless of race. Or given a man and a woman with the same level of qualifications and experience, they should be hired at the same rate. So it's conditional on something that makes them equally situated. And this can be translated into a mathematical notion. And it invokes, you might call it equality of opportunity as a moral principle. But this is not the only way to think about fairness. So when we make charts like this, where we look at the, let's say, gender breakdown of employees in technology companies, we are implicitly invoking a different definition of fairness. We're implicitly saying, if we don't have the same number of male and female employees, there's a problem. That is a different idea of what we should be seeing in our data, and it actually corresponds to different mathematical and legal principles. The legal concept, you're probably familiar with this idea of disparate impact, which is encoded most famously in a rule called the 4/5 rule. So this is actually law. This is just a quote from this piece of the federal code. And this was established in 1978, and it gives a threshold that says, now this is not the gender composition of the company, this is looking at hiring. It's this word selection rate. They're talking about how many of the people you interviewed did you hire, right? So it's not quite the same thing, but it's looking at the output of the process as opposed to the input. It says, we don't care what they walk in the door with. If you're not hiring them at about the same rate, there's a problem. So as a statistical concept, this is called demographic parity. And the idea here is that you should have you should be choosing people or assigning people or classifying people or granting them some favor or some penalty at a rate corresponding to just the general population statistics. Now, this may make a lot of sense for hiring. It may not make sense to you in the criminal justice case, right? Should we give sentences to people exactly the same way, regardless of race? Or should it be based on criminal history in some way? So these different definitions of fairness conflict, and we have different intuitions about what is the right definition of fairness in particular cases. In particular, applying the wrong definition can sometimes lead to nonsense. So you can get you can get demographic parity by randomly picking people between two groups, right? That satisfies the statistical definition. It may not be fair in any other sense. Now we get to the ProPublica story, which you just saw. The core of that story, as I read it, is the observation that the false positive rate was higher for black defendants than white defendants, right? And so this is the key table in the story. This is an argument about a different definition of fairness. And it's a type of fairness that also appears in the statistical literature. And what you're saying is equal error rates. And it's an appealing concept, right? An error is a punishment of some sort. Either you didn't get a loan and you should have, or you got held in jail and you shouldn't have. And so we would like the error to be balanced in some way. You can say that there is a moral principle here, which is equality of opportunity, or a legal principle, which is disparate treatment, in the sense that you want it to be wrong across the same for both groups and not just right across the same for both groups. So, which one should we use? Well, that depends on what we're talking about, and the real world, as usual, is more complicated than these sort of simple formulas. So I'm going to talk about what this looks like in a broader sense. This was a graphic originally due to Craig Frohl, which kind of illustrates two of the notions of fairness. And different people have different intuitions about what it's appropriate to apply in each case. You may think for healthcare that the picture on the right is more what you want. People start in different places and we treat them differently to assure the same outcome. You may think that for college admissions or criminal sentencing, that everybody should be treated the same way, given the same crate, and if they end up in different places, that's because they showed up with something different. And different people will have different intuitions about what the right definition of fairness is, even for the same problem. Right? This is tied in very much to the affirmative action debate. Unfortunately, you can prove that the three definitions of fairness that I showed you, so calibration, demographic parity, and error rate parity, are mutually contradictory if the groups have different characteristics, right? So if not everybody is going to be rearrested at the same rate, if people are coming in with different qualifications, if people are more or less likely to repay a loan in an actuarial sense, you can't actually have all of these definitions at the same time. So what to do? Well, it gets even worse. Even the things that you hope are reasonable measures of fairness can be gamed in various ways. So, for example, the false positive rate can go down when police start arresting more people. So if you use the false positive rate as your target for fairness and try to equalize the false positive rate, you can actually end up harming the community you were trying to help. And this is a particularly vivid example for false positive rate, but you can find examples like this for other definitions of fairness as well. So you got to be really careful about how you set up the incentives. And so far I've just talked about algorithmic output. It turns out that people may or may not follow the output. So there's been a lot of concern over people like slavishly following the algorithm output and sort of losing the humanity in the process. This isn't what actually happens, at least in the case of criminal risk scores. And you can see this when you look at the actual outcomes. So risk scores are being implemented in a lot of places with the promises of releasing more people without bail. Did that work? Well, along the top here, you can see what happens when various laws came down, and you get a jump in release rates, which then gradually slides down until the next edict from on high. What's actually happening is there's some change initially, but then judges eventually just go back to what they were doing before. So fairness has to include more than the algorithmic results. It has to include what people are doing with it. Are they gaming the system? Are they using it? Are they ignoring it? Anyway, so these are some of the challenges to trying to determine fairness just by looking at data. You're going to need something else. You're going to need to look at not just the data that is produced, but the whole rest of the system. And I would argue that the right way to think about these is not, is the algorithm fair, but to reframe it in a couple different ways. So first of all, compared to what is an incredibly useful question. If you're trying to analyze a piece of software that is going to be used in criminal justice, in schools, in lending, what are the options? And you're not going to get sort of perfect abstract fairness. You might say, well, let's do the best we can given the limitations of the data. But it's also important to ask, well, how do humans do? And humans often do not come out very well in terms of these quantitative fairness measures. This is why there are so many people pushing for risk assessment in the criminal justice system to begin with. And then not just compare it to people, but compare it to other types of reforms. You know, what else could we do here? And this makes it a more meaningful choice. And then a lot of these problems hinge on prediction, right? If historically in Broward County, this is certainly the case. We know from the incredible work you did getting all of that data. Black defendants are rearrested at a much higher rate than white defendants. Well, what does that mean? That's some combination of policing bias and a difference in underlying reoffending. And there are huge arguments as going on for the last century as to how to interpret this disparity. But if the prediction tells you that in the future we should expect more black defendants to be rearrested, that doesn't mean the prediction is biased. That means the prediction is working, right? So then you have to ask, what do we do with the prediction? And one answer is to say, well, we should throw people in jail if they're predicted to rearrest. And another answer is to say, well, these people need more help. We should be looking at some type of intervention. Right, so the bias there may not be in the predictor, but in our use of this knowledge of the future. Finally, I want to point out that the biggest piece of proposed algorithmic fairness legislation does not define the term fairness. This is the only place where the words fairness and bias appear, and they don't say what it is. So I think this is actually a smart move. What this legislation does instead is it says, if you're going to use one of these systems, you have to write one of these automated decision system impact assessments that lay out your justification for using the system and using a particular definition of fairness. And that, I think, is the appropriate journalistic entry point as well. There's not going to be a one-size-fits-all definition of fairness. You can't just open a spreadsheet and calculate something and say, is this fair? You have to say, is the choice they have made in using the system reasonable given this context? And do I agree with the definition of fairness they have decided to use?
This is a Ron Wyden.
Yeah, that's the Ron Wyden proposed bill, yeah. All right, that's all I got. Here are some resources that I have found particularly influential and interesting. And I tweeted this whole deck, so don't worry about trying to grab all of this. Thank you.